Alright, this is Algebra 2, Section 1-3, Algebraic Expressions. The essential question is, what are some ways you could use algebraic expressions to model real-world problems? And let's begin. So we're going to start off with converting word phrases to expressions, because this unit's about writing expressions, like reading information and writing that expression. So I think the basic form is, here's a word phrase, write the expression. So 32 more than a number n. So number n is our variable. So I'm going to put an n. When I say 32 more than means adding. So I'm going to go n plus 32. Alright, 58 less than a number n. So n is still my variable. And 58 less than that. Well, less than, we're subtracting, so that's minus. So is this 58 minus n, or is it n minus 58? But think about this. 58 less than a number. So we have a number, and we're going at 58 less than that, so I'm going to go minus 58. 8 times a number n. So times means multiply. 8 times a number n, so I have an 8 and times an n, just like this, 8n. The quotient of a number n and 5. So when we say quotient, we mean divide. So the number n and 5, when we say it like this, n goes on top, the 5 goes on bottom. So those are different ways to take a word to an expression. Let's try something else. So the whole point of this is figure out how to model situations. It's not just going to be like a half a sentence fragment and you just write an expression from that. It's going to be a real world problem, and you have to figure it out and create an algebraic expression or equation that models it. So here's the steps when I try to do this. And this is going to separate the good, A students from not A students. You have to be able to do this. Even if you're not an A student, everyone should be able to pull this off. And it'll take some practice. So how do you model a situation? First, you want to identify operations. So you just read the question and start identifying like parts of what's going on here. So if it's like adding a number, subtracting number, multiply or divide some number or variable, and maybe if there's a number associated, you write down the actual number. I mean, if it's saying we're adding 20 eggs every day, that's something plus 20. So identify those and probably circle or highlight those. The next step you want to do is define one or more variables to represent unknowns. So you got to figure out what's your unknown here. And sometimes those are, you look for the question, it'll tell you what your unknowns are. It's whatever other nouns are in there. But you have to really look through that, because what you think might be an unknown, just read it very carefully and think, do I actually know what this value should be? Because it's not always obvious, and you'll see with some problems. So define those unknowns, and then when you define them, you actually say, I'm going to say x equals, I don't know, the number of days. I'm going to say y equals, I don't know, number of basketballs, whatever the problem is. It actually has to stand for something, okay? So you have to not only just figure out what those unknowns are, you write down the definitions of them. This represents that, this represents that. Create an expression. So once you have your operations and you define your variables, then you can start creating that expression using the operations and the variables. So let's see how that actually works out. So here's an example, and write this down. You start with $20 and save $6 each week. What algebraic expression models the total amount you save? So first I want to identify operations here. And just reading through this, it says you start with $20. So start with $20. This is my first operation here. When I say I start with that much, I'm thinking like I'm adding that to my pot of money. So that's start with sounds like an add thing. So we're probably adding a plus 20 somewhere. And then we have this other operation. We're saying saving $6 each week. So this is another thing. So every week, and since this happens more and more, if it's something that keeps repeating the same amount every time, that's usually going to be some kind of multiplier product. So it'll be 6 times something. So I'm going to write 6 times something. I don't know. Those are the operations I know I'm going to do. What algebraic expression models the total amount you save? Okay, so that's it for operations. So I know I have a plus 20 from with this. You start with 20, and then the 6 times because we're adding 6 on some kind of increment here. And keep adding the same amount every time. That's going to be multiply by however many increments we do. Now define one or more variables to represent unknowns. Alright, so what are my unknowns? Well, the first thing I see, looking for your nouns here, you start with, and save $6 each week. Okay, so week. Do I know how many weeks there are? Sometimes the problem might say, oh, it's only 3 weeks. So you don't just assume that's the unknown. But, well, total amount you save. Okay, so we don't know how many weeks we're doing it. That's the whole point. So one of my unknowns is going to be week. I'm going to say that's going to be x. So x equals weeks. How many weeks have gone by? So that's my unknown. Now reading the rest of this. What algebraic expression models the total amount I saved? Okay, so this is another thing. What's my total? That's actually going to be another variable here. I'm going to call this y equals total saved. Because we don't know that. That's what we're trying to find out. Like, one way you can find your unknowns is look what the question is actually asking you to find. Now I'm going to break the rules here. It says algebraic expression, but I'm going to turn it into an equation because it works better if we have two variables like this. So I want to create the expression. Well, you have to figure out your total saved. That's what you want to find. So I'm putting an equal sign. That should go on one side of the equal sign, so that's going to be my y. So I'm going to put my total saved in my y. What is the equal? On the other side is the expression. This is where the expression goes of the actual money I saved. And there's a few parts of this. Part of this is I added $20, so I'm going to put a plus 20. That only happens once, so it'd be just a plus 20. Now I know x is my number of weeks, and I saved $6 each week, so it's that 6 times, that's actually going to be 6 times my x. So 6x. So my expression's right there. Well, this is an equation, but y equals 6x plus 20. If you want to adjust the expression part, it'd be the 6x plus 20. So that's how you create an expression. There's a process to this, so make sure you write this down, and the more you practice it, the better you'll get at this. And no, I believe in you. Trying again. Okay, evaluate. When something says evaluate, you want to substitute the values in and simplify. So for example, what's the value of this expression? 7 times the quantity a plus 4 plus 3b minus 8. We're substituting negative 4 for a and 5 for b. So plugging those in, I'm going to write this as 7 parentheses. And whenever you're plugging in, just get in the habit of putting in parentheses. Because sometimes you lose the order of operations if you don't. I know in this case you probably don't have to, but just do it. So negative 4 plus 4 plus 3, and then I'm going to do parentheses b, so 5. So 3 times 5 minus 8. Now follow my order of operations. Do parentheses first. Negative 4 plus 4, that becomes 0. So I got 7 times 0 plus 3 times 5 minus 8. And then my next step, well, 7 times 0 goes away, so that 7 times 0 is 0, doesn't matter. 3 times 5 is going to be 15 minus 8. My last step, 15 minus 8, is going to be positive 7. So my answer is 7. All right, some more vocabulary. Write this down. So a term is a number, variable, or product of numbers and variables. So it could be a number. So it could be 5, negative 1, 1/9. Could be, let's see, 22 hundredths. You can write it like that. These are all numbers. These could be terms. They could be variables, x, y, z, whatever. Those are also terms. Or they could be product of numbers and variables. So product means multiply. So it's doing things like 2x, doing 3y, negative 4z. These are products of numbers and variables. And you could actually do them more than one. So you could also do 10x, y, or you could do 15 y cubed z. These are all different types of terms. Okay? Coefficients is the number next to the variable. It's the number in front. That's what I'm going to call it. So if I had the case of 2x, my coefficient is going to be this 2 right here. That is the coefficient. Constant term is just a number with no variables. So that 5, negative 1, 9, these are all constants. 5, negative 1, 1/9. It's just a number, no variables. So taking this example down here, we got a few things. We got our coefficients here, negative 4, 7, and negative 6. All these three things, I'm going to do an arrow, these are coefficients. So coefficients. Another thing, if I want to say our terms. Now, our terms, another way to say terms is they're separated by plus and minus. So we're going to say separate by plus and minus. Write that in for terms. I think that's an easy definition. So in the case of this expression down here, I can separate by the pluses and minuses, and I count my number of terms as 1, 2, 3. So we have 3 terms. And what are my constant terms? Well, it's the one that just has a number, and that'll be -6. So this one right here, this is going to be my constant. Alright, like terms. So like terms are when they have the same variables with the same powers. Same variables, same powers. What does that mean? So they have to have, if one of them has x, the other one has to have x. The other one can't just have y, or that doesn't work. Those aren't like. They also have to have the same powers. So x squared and x cubed, these are not like terms. That doesn't work. But we could do 2x squared, and we could do 3x squared. These are like terms because they have the same powers. 2 and 2 for x. So this would be okay. Now take this example here. What are like terms? Well, and what I like to do when I combine those like terms, I like to underline them consistently. So I'm going to take this x squared. Since it's squared, I'm going to underline it 2 times. And any other x squared terms, I'm going to underline 2 times. So 5x squared, coefficients don't matter. Now x cubed z, no, that's too many x's and there's an extra z, so that doesn't work. yz, nope. Y cubed z, nope. So these are like terms. Are anything else like terms? 9x cubed z. There's no other x cubed z's. This is y cubed z. So nothing else is like terms. Our only 2 like terms are these guys. Combining like terms. So this is where I took my 2 like terms like this, and I combined them into one. If I have 3x squareds and 5x squareds, they combine to 8x squared. So sometimes you're going to see problems when you're trying to solve, and you'll want to combine like terms first. It just gets rid of extra terms, and it's a lot easier to solve a problem. It's usually one of the first steps you do in solving. Things look really big. So let's try this. Pause the video, read the example. Alright, let's begin. So this is, you have $150, but you are spending $2 each day. What algebraic expression models this situation? So we got to write an expression. So my first step, well, go back to my notes. What's my first step? First step is identify operations. So I'm going to identify the operations going on here. So at the start it says you had $150. So it's like you have that at the start. So for operations, you're going to have $150. So I'm going to say that's a plus 150 because that's what you start with. All right. It says you had 150, but you're spending $2 each day. So when you spend, that means like you're losing that money, so it's subtracting 2. So it's a -2, but it's each day. So it's $2 every day, and over however many days, whenever that something keeps repeating like that in a pattern, we're multiplying. So it'd be -2 times something. -2 times something. I'll put a dot. Okay, so those are my operations here. Now I got to figure out my unknowns, my variables. So my variables here, well, what don't I know? You had 150, but you're spending $2 each day. Okay, so each day here, maybe this is a variable. So do I know how many days I'm spending? Let's see, what algebraic expression models this? I don't know how many days. It doesn't say. So this is my unknowns. I'm going to call this D for days. So I want to define that. So my variable is D for days. What algebraic expression models this situation? Okay, so I want to model the situation of how much money I have. So D for days, and here's my operations. I'm multiplying -2 times days, right, for my operation. Well, my days is D, so it'll be -2 times D, which is just -2D. And plus, I had 150 at the start, so I'm going to do a plus 150. And there's my expression, -2D plus 150. All right, pause the video. And let's try this. So value of the expression, we're going to plug in 1 for x and 1/2 for y. So plugging in 1 for x, I'm going to get 1 over 2 plus 1/2 squared. Okay, so 1/2 is good. 1/2 squared. What happens when we square that? Well, that 2, power of 2 is distributed to the numerator and denominator, so it becomes 1 squared over 2 squared, which is going to be 1 squared, which is 1, over 2 squared, which is 4. So 1/2 plus 1/4. Well, how do we add those? We want to have common denominators here. So I'm looking for the LCM, the lowest common multiple. 2 and 4, that's going to be 4. I want to multiply the left fraction by 2 over 2. So on the left, we get 2 over 4 plus 1 over 4. And with common denominators, they add up to 4 on the bottom. 2 plus 1 is 3. So the value for this expression is 3/4. Last one, pause the video. Alright, going to simplify and combine like terms. The first thing you want to do on the top is we want to distribute that negative and distribute that 2. So this negative, which is like a -1, is distributing to both those, and the 2 is distributing to both these. So -1 times 3k is -3k. -1 times m is -m, plus 2k minus 8m. Now I want to combine like terms. So combining like terms, well, the k's are like. -3 plus 2 will be -1k, or just -k. And the m, -m minus 8m, is going to be -9m. So there's my answer, -k minus 9m. The bottom one, okay, I don't have to distribute, but I combine like terms. So j squared, another j squared, that's like 1j squared. So -4 plus 1 is -3j squared. And then what else? Let's see. There's a k, but there's no other k's. And there's this j. It doesn't combine with the j squareds. So these guys are by themselves. So it's -7k plus 5j. And there's your simplified form. That's it.